Okay, if you are at home, we're going to be working with scale factor in class. Scale factor is has to do with similar shapes, just like we've been working with. We've been working mainly with similar triangles and finding missing sides. Okay, there's something else that we haven't talked about yet, and that's scale factor. Okay, one way we could think of two similar shapes is scale factor. Scale factor is the number that each of the sides of one shape is multiplied to get to the other shape. Okay, it's a multiplier. In this problem right here, okay, we have quadrilateral LMNO, and we have quadrilateral STUV. Remember, quadrilateral is just four sides. Okay, and we are multiplying. See, notice that 5 is multiplied by 3 to get 15. 2 is multiplied by 3 to get 6. Okay, and the other 2 and 5 are also multiplied by 3. Okay, so they're similar, okay, because they're proportional. Okay, but we're just now looking at simply the number that we're multiplying by. Okay, and we are multiplying by 3, so we're going to say that the scale factor of this problem is 3. So if I am given two sets of similar shapes, I can find the scale factor if I know what the sides are. Let's look at this first one. These are two trapezoids. Okay, they're similar. Okay, one's enlarged from the other. Okay, notice that to get from 2 to 10, I multiply by 5. And to get from 3 to 15, I multiply by 5. Okay, to get from 5 to 25, I multiply by 5. Okay, so that's called the scale factor. So the scale factor for that problem is 5. Okay, take a minute, pause the video, see if you can find the scale factor for the other two problems. Okay, the next one looks like we have two pentagons. Okay, to get from the first shape to the second shape, every corresponding side is multiplied by 6. 2 times 6 is 12, 4 times 6 is 24, 3 times 6 is 18. Okay, so the scale factor in that problem is 6. Okay, the scale factor for the last problem here, okay, we go from 5 to 15, we go from 5 to 15 again, we go from 7 to 21, and from 2 to 6. Okay, we're multiplying by 3 every time. Okay, so the scale factor is 3. Okay, so I want you to know what scale factor is. The multiplier. I want you to know how to find it, and I also need you to be able to, if I give you an original shape, and then I give you a scale factor that I want you to multiply by. Okay, I want you to be able to find lengths and widths, the perimeter, and the area of the new shape. Okay, and that's what the last few slides are on here. Okay, so let's say we start with this rectangle on the left. Okay, it's a 3 by 5 rectangle. Okay, and I want to enlarge it with a scale factor of 4. So what I want to do is I want to find the length and the width and the perimeter and the area of the new shape. Okay, after I've applied the scale factor to it. So first thing I need to do is multiply by 4. Okay, to get the new side lengths. So 3 times 4 would be 12 centimeters. 5 times 4 would be 20 centimeters. Okay, and from there, I can find the perimeter and area of this new shape. Okay, the perimeter. Okay, I'm going to add all 4 sides up. 12 and 12 and 20 and 20. And that gives me, let's see, 20 and 20 is 40. The 10s make 64. 64 centimeters would be the perimeter. Right there. Okay, the area of a rectangle. Okay, for a rectangle of an area, you take length times width. So we need to take 20 times 12 to find the area. Okay, and that'd be 240 centimeters squared, square centimeters. Okay, let's do another one. Let's do a triangle. Okay, we have a triangle. The triangle on the left is enlarged with a scale factor of 3. Okay, I want you to be able to find the new sides of the enlarged shape and then the perimeter and the area of that shape. Okay, maybe try to pause the video and do this on your own and check. Okay, so when we have 3, we're going to multiply that by 3. So we have a new base of 9 centimeters. Okay, 4 times the scale factor of 3 would be 12 centimeters. 5 times the scale factor of 3 would be 15 centimeters. Okay, so that's the sides of the new shape. Okay, from there, the perimeter. Okay, perimeter just means add up the 3 sides. So when I add up, let's say 12, 15. When I add up 12, 15, and 9, okay, I get 36 centimeters. Okay, to find the area. Okay, now this is a triangle. Okay, this is a triangle. To find the area of a triangle, remember that's 1/2 times the base times the height. Okay, remember the base and the height are the 2 sides that form the right angle. Okay, so the 9 and the 12 would be considered the base and the height. So we need to take 1/2 times the base of 9 times the height of 12. And you know what I'm going to do? Because I want to do this without a calculator. I'm going to take that 12 and 9 and reverse them. Because I can figure out 1/2 times 12 easier than I can figure out 1/2 times 9. Okay, 1/2 times 12 is just half of 12. Okay, half of 12 is 6. And then I'm going to take that times 9. Okay, and I get 54 square centimeters. Okay, so again, we wanted to use the scale factor to find the new side lengths and then find the perimeter and the area. Okay, 2 more problems. Okay, we want to be able to do the same thing to a circle. Okay, the circle on the left is enlarged using a scale factor of 2. Okay, so using that scale factor of 2, find the new radius, and then instead of perimeter, okay, find the circumference, and then the area of that circle. And I'm going to recommend you pause the video and try this on yourself first. Okay, so radius is 5. Okay, if I need to apply the scale factor of 2, it's going to multiply that 5 times 2. So my new radius is 10. Okay, so now from that radius of 10, I can do stuff. I can find the circumference and the area of that circle. Okay, now I was trying to encourage you guys to use pi times diameter for circumference instead of 2 times pi times r. Okay, but you could do it whichever way you want. So I'm going to use pi times diameter. Okay, you know what I should do? I should go ahead and make a note that my diameter is 20. Okay, so if I'm going to use my second rule, that the circumference is pi times diameter, I need to know that the diameter is really 20. Okay, the diameter is all the way through the center of my circle. Okay, 10's only halfway through. So I'm going to use the diameter of 20, and then I'm going to take 3.14 times that diameter of 20. Okay, I'm using a calculator. I get 62.8 centimeters. Okay, 62.8 centimeters is the circumference. That somehow. The area of a circle is pi times radius squared. Okay, you may want to think of radius squared as just r times r. So my area is going to be 3.14 is pi, okay, times radius. So 3.14 times 10 times 10. Okay, and if I take 3.14 times 10 times 10, I'm going to get 314 centimeters squared. Okay, so again, we use the scale factor to find the missing side length, or the new side length, and then we found circumference and area instead of perimeter and area of the new shape. Okay, definitely try this last problem on your own. Definitely try this problem completely on your own before you check it. Okay, so we have a rectangle that is 10 by 12. Okay, we're going to enlarge it with the scale factor of 2. So I want to find the new dimensions, the length and the width, and then I want to find the perimeter and the area of this new shape. Okay, so if the scale factor is 2, I want to multiply 10 inches by 2. Okay, that's going to be 20 inches. I'm going to take 12 inches times 2, 24 inches. So that's the new length and width, okay, of my enlargement. Okay, I need to be able to find the perimeter, which is adding all the sides up together. So 20 plus 20 plus 24 plus 24 is 88 centimeters. Okay, the area of a rectangle is length times width. So I need to take 24 times 20, which would be 480 centimeters squared. Okay, that's all the problems. I just wanted to get a really brief look at scale factor and kind of the real basic types of problems. I'm not going to hit this as hard as I normally do, but just make sure you have the slides completed. Please let me know if you're having trouble with this. Okay.